So, all right, guys, let's continue with the next part. Um, if we guys think about the concepts that we have discussed yesterday, is it is a it is a great concept actually, because normally if you talk about the infrastructure, right? Yeah, but yeah, if I summarize, right, if I summarize whatever we are doing, maybe we are using a cloud, maybe public cloud or a private cloud, or maybe we might using Kubernetes or Docker, or depend guys, maybe your virtual box and your systems and servers. The final perspective is we have to deploy our applications. Okay, maybe website or web apps. That is always the final motto. Okay, but before we deploy any application, right, we have to create a proper environment for that particular application. Okay, and when I say environment here, I mean to say we have to create a proper infrastructure. Okay, that will give the application a proper resources in the terms of RAM, CPU, in the terms of physical hardware, in the terms of data center, in the terms of networks, and plus in the terms of security also. Okay, so we have to properly plan it. And that is the reason, guys, when you go for any of the admin training, or here we are into the architecture training of the AWS cloud, right? So the tools that AWS provide, for example, VPC is one of the tool. VPC, they are the one who helping you to plan your network or your infrastructure on the top of the cloud. And say they say we are customized, right? We are customizable according to a requirement. What you need, plan it, right, create the environment, and after the environment, or I can say the infrastructure has been created, now the in the future just go and deploy the application. That's all. Okay, so guys, if I very quickly summarize my yesterday class, so was very important, guys. I highly recommend, by chance if you miss that particular class, ask for the recording, go to the recording. And if you guys gone through my yesterday class, the the infrastructure that we had built yesterday, and just go through it, and also create by yourself. Okay, because this is the core, not for the AWS. If you go to Azure or if you go to GCP, the same kind of infrastructure we normally have to create. And on the on the top of this, we have to start building multiple things. So you will also see, guys, when I go for some more advanced things, maybe in the networking, or maybe if you use some other service like load balancer, this would be the basic thing that we had created yesterday. Okay, and it is again not the, it is not matter much. For example, somebody might say we are the data guys, means we would like to make our career in machine learning, or maybe in AI, or maybe big data. Wherever you go, you need application, right? And where the application running, you have to deploy it. But it is always good, before deploy, you should know your environment, right? What kind of infrastructure you are in. Either you have to create or somebody has to create, but it's good always, at least you know the basics, so you can properly plan some more extra things for your applications. Okay, so if I very quickly if I very quickly create again give you what we had done yesterday, so we can create some more new thing on the top of this. So we had created, guys, one office means network means VPC. So one VPC we have created, and we had planned, right, we have planned that we have to launch multiple instances here, plus maybe not the instances. Okay, because you want to launch the OS, if you want to launch the OS, that OS in the AWS, you have to launch using a service called EC2. Okay, but maybe in the future you might have to launch might have to launch the OS with the technological container, like for example, maybe Docker, or maybe with the help of Kubernetes. Okay, so there also, finally it launched the OS for you, where you have to run your application, right? But that time also you have to decide when, in which VPC lab or subnet you would like to launch the OS. Okay, so maybe in my future classes I will talk a little bit about ECS services or EKS services, about Kubernetes or about Docker. We'll discuss that. But wherever you go in the future, you need premises, or you need a VPC. Or in the VPC, plan, because we know there might be requirement in the future that some of the operating system, right, we have to provide internet connectivity, and some of the system we have to make it isolated from the entire world to give them extra security. Okay, so the lab that you create inside this VPC, that's called subnet, and the subnet that where you give internet connectivity is called public subnet. So in the public subnet, guys, you can launch the OS. Okay, that if you launch the OS from the EC2, then this OS is called operating system, or I can say instances, or maybe you can use the term here called virtual machine. Okay, but if you launch the OS with some other services, not the EC2, for example, one of the services called ECS is called Elastic Container Services that we haven't discussed yet. So if you launch the OS from that service, then this OS is typically known as a container. Container. But any of the way, finally the need of the OS is to deploy or to configure the applications. Okay, but in any of the cases, both the OS will have a outside connectivity. Means anybody from the internet, they will reach to your VPC, and in your VPC they will reach to the public router, or I can use the word called public facing router. This is also, guys, one word we use. That router has internet connectivity. Or here we also use the word called internet gateway. So they hit to internet gateway, or this internet gateway will have a public IP, and will tell the router that anybody who come to this public IP, let's say this router has a public IP 1. So anybody who come to this public IP, so we have one OS running here, 192.168.1.10. So create a DNet rule and send the request to IP 10. But maybe you have a requirement, you have a requirement, we would like to connect to this OS also. I also want this OS will have a internet connectivity. Okay, or somebody from the internet connect to this OS. Okay, maybe from ECS or EC2 services. So let's say this OS also have some IP address. Let's say IP is 192.168 1.11. So if you're two instances running inside a public subnet, and obviously I want I want in my router we have public IP, for example 1.2.3.4. So I'll tell my router, if anybody come to this IP, so in this case, connect to the IP number 10. That's called DNet. But if somebody want to connect to IP 11 or to this OS, how they connect? In this case, in this router has one network card. But guys, in one network card, there's a way we can provide multiple IPs. So again, I'm repeating, guys, it is not the case that if you have one network card, you can only give one IP. Okay, there's certain way in your operating system, in one single network card, you can assign as much as IP you want. Right, and very quickly, as I'm just going to show you one small demo in the Linux, but we can do. So in one single network card, we can add one more IP. Let's say the IP may be 1.2.3.5. And I'll tell my router that if somebody come to you on the same network card for this IP address as the destination, you have to do DNet and connect to the IP level. So it means in your subnet, if a 10 different computer, so over the 10 different computer, we can provide internet connectivity. Anybody from internet, they can connect. For this, you have to keep on assigning the IP to the internet gateway. And for every IP, we have to create a denetting rule for their respective systems. Okay, and sometimes it's also known as we have to attach a pool of IPs to the router, and this is the way actually we work. Okay, so this is one of the guys query somebody asked me, so I just wanted to elaborate a little bit here. Okay, and all this custom guys connect to the switch that you guys know, and this switch will have their own router for this particular lab connectivity, and this router will have this final connectivity. So this part, guys, we have done successfully and working very great. Okay, so today's, guys, my plan is a little bit different, but till here we have discussed and we have done successfully, and there is no challenge, right? So everything was working fine, and every steps, guys, I explain you, even though what is meaning of routing table, how to connect the routing table with internet gateway, and subnet association of the routing table, everything we discuss. Okay, but we have because according to our plan, maybe we might have some certain requirement where I would have to launch some instances, they won't have a internet connectivity. Internet connectivity. So example, this might be one of my OS. Let's say this is my database server, I don't want anybody directly connect from the internet. Okay, but because this OS is launched in this subnet, and both the subnet public and private belong to same VPC, so somebody from public can go to private, they have a that connectivity. And guys, as you launch the OS, they also have switch, they also have their own router, and all the router has a connectivity. So everything is working. This, guys, this part also we have discussed. Okay, yesterday. Now, this network infrastructure we have built and was working fine. But in this network infrastructure, guys, we had one issue. Okay, and what is that issue? I will first try to show you that issue, right? And then we'll move to the concepts where we will try to resolve that. Okay, but guys, yeah, before this, if you want to know the today's agenda, agenda, guys, so we are going to discuss one of the topic called NAT gateway. Is again one kind of specialized router in the AWS. This is one of the things we are going to discuss. Second thing, we are going to discuss about NACL, about the security, and there's some more basic options in the VPC available. We will discuss today. Okay, so these are the main topic for today. If we got the time, we might discuss new topic, but this is my main plan for today. Okay, so let's see, guys, what kind of challenge we have first, then we move to the next part. Before this, just as a small demo, it's not at all the part of AWS training, but anybody who know a Linux operating system. So right now in my Linux, I ifconfig is a command, and if you see here, I have one network card. It's called ENP0S3, and if you see ENP0S3, this is the IP address associated with this network card. But guys, there's a way in the Linux operating system, in one network card, you can associate as many as IP you can. So in the Linux, guys, there's a command to change the IP, but we'll change the IP on this network card. For example, IP change. But my plan is not to change the IP. I have to add more IP. Okay. So for example, I will have to add this much IP also. Okay, so for this, guys, what can you do? There's a way you can create a virtual network card. A network card is one only real, but in this real we can create sub or virtual NIC card or network card. So for this, you have to use colon one. Okay, so now what do you see? This network card has this IP, and this network card has this IP. Both the network card is same. And how I know? So every network card has a hardware address called Ethernet address or MAC address. So you guys see the MAC address of this network card, and this is same, but the IP is different. So if you want to add more IP, just keep on giving uh, some other IP of any of the range or any of the number, whatever you feel like. Even though if you run ifconfig command in totality, you will see now we have one, two, three network card. Actually, it's one, but one single network card has multiple IPs. So similar kind of approach you can think router also use. Because mostly router in the world actually built on the top of Linux OS only. So if you go to Cisco router OS name is called iOS. iOS also built on the top of Linux only. So this is a very common concept for all the routers, right? So that's a different point. Let's come to our main topic. Okay. So I'll go and connect to my AWS. So guys, this infrastructure I already have, and it's running the way we launched yesterday. And I told you guys one more vocabulary, because we don't have direct connectivity from this OS. And how I know? There's two reasons. First of all, this OS don't have a public IP. Plus, this OS, let's say this is OS number A, this is OS number B, or let's say this OS number C. So OS number B plus don't have, or plus I can say the entire lab router that give me the outside lab or outside world connectivity, they don't have actually an internet line from the internet gateway. So there's no physical connectivity, so there's no meaning that this private, any of the OS will go to outside world, and nobody can come in also. So both the sides. Okay. So that is the reason, if anybody want to reach here and who want to reach, obviously we are the one who would like to reach, because if I launch the OS here, so intention is, right, technically, as the AWS perspective, we might have the AWS account, but technically we are sitting in the internet. So you can launch the OS from the AWS portal, but after launch, if you don't able to log into this OS with the help of SSH or maybe some other protocol, how can you configure this? So at least you as an admin of your account should have a some way so you can reach here. And for this, I told you yesterday, for this we launch one OS in the public subnet, let's say A, and we say A, we launch you not for you to, not to use you, so we will land on you, and from you I will go and connect to this OS. So for me, you are the bastion host. Okay, but so it means it means first you have to log into this guy, and second, after log into this guy, then you have to log into this guy. And obviously, guys, if A want to log into B, so A require username, A require IP, and A require password. But by chance, A don't have the password. Okay, and guys, here the password. Normally, we use instead of password, we have to use a key that's called SSS key or a private key. So nothing is special here, but I'm going to show you. I'm going to first provide a private key to the A and private key for the B actually. But I will copy the private key to A, and A will use that private key to log in to this guy. So pretty straightforward topic, but it's not my main topic. But after I reach to this system, when I landed or log into the system, then I will start the main topic for today. Okay. So this is one of the account. Okay, and we have done everything in the Virginia region. And let me go for issue to services and plus VPC also. Okay, so two instances were running, and I told you yesterday this instance running in one means public network, and the IP of this guy is this one. This one. So what I'm doing here, I'm just copying this guy, connecting this guy. Pretty simple. I just connect from here. So from my laptop, from my laptop, I have connected to A, or maybe you can use Putty program to connect. So we have connected because we have done yesterday all the connectivity part. Okay, but from here, if I try to connect to second computer, that we can connect, no challenge, right? So I can connect to my computer number second, that is running in the different subnet. Subnet number 2 they are running. Okay, so subnets here, subnet 2 they are running. So we can connect because we have a connectivity. So I can use this IP, and after I use this IP, I can just try to ping. So they have a connectivity I already showed you yesterday, and I can do SSS also to connect this guy. But challenge is, right, if I try to connect this guy, my computer, this one where I am in right now, requires some password, but here they're not looking for a password, they're looking for some kind of key that's called private key. And if you do ls here, I don't have a private key. Okay, so if you see guys, this OS say if you want somebody want to log in, they require a private key with this key, SS key Mona account US. Okay, so because guys, initially I have created this key and I downloaded it in my laptop. So maybe I don't know, SSS key Mona account underscore users. I don't know I have this or not right now. Yeah, I think somewhere I have. So in my downloads folder, I have this key in my local laptop. But I'm not logging from my local Windows. I am logging from my this OS. So I have to first upload this key over here. And how to upload, guys? Key is a file, so you can use WinSCP. So upload. It's a pretty straightforward thing, nothing special, but I'm showing, maybe some of you guys might don't know how to use this process. So from my laptop, I'm uploading this key to A. After A has a private key or a password of the B, then they can log into B. Okay. So for this, A require the IP, means my laptop require the IP address of the first computer. Okay, I'll use 1 minute. Okay. So this is IP address, and the username is ec2 hyphen user, and I don't have a password, so I'll go to advanced, and by chance I have a key, private key. That's called SSS key US something. I use this key. Okay, well guys, they doesn't support PEM format by chance here. They doesn't support in the PuTTY or WinSCP. So give me very quickly, let me PuTTY gen. So let me very quickly convert. So guys, this part we know, pretty straightforward. Initially we discussed already, right? So let me convert this key into PPK format, save the private key, yes, with the SSS key, same name, extension, they want to pick for us .ppk. That's all. The file PM is converted to PPK. And let me use PPK format over here. Okay, okay. So you get this part, you know, is nothing very fancy here. That's all. So finally, from my laptop, I connected to this OS. Nothing is here. Then I will transfer. So what I would like to transfer here, I will transfer a private key for the B, where I'm transferring to the A. So you will have private key so they can log in. Okay, and understand one thing here. A is a OS, and this OS is Linux. And in Linux, I'm going to use SSS command to log into the system. And guys, SS command support PEM format by chance. That doesn't support PPK. But it is a program that support PPK format. SSS support PEM. So I have to transfer PEM format. I'll go to my download folder, and here to search, maybe this one. 1 minute, please. Yeah. So let me transfer. So that's all, guys. The private key has been transferred. It's called PEM format. I transferred here. So now if you do ls, the file transfer. That's all. Now again, if I try to do SSS to this guy, okay, this guy. So right now I'm into the system number A, and from the A I'm logging to B. Again they fail, but because I have the key, so I can use one option called I means identity, or I can say key, and my key is located in this file. Now guys, this time again they fail, but there will be new error come up. So by chance, if anybody know Linux, so this file has a read permission to all the guys. So I'm changing the permission to 400. That makes the file not readable by other guys. And then only SSS can use this command. Okay, so let me share this command. You guys might know, but let me share this command to you. That's all guys, log in. So if you guys see here, I was in IP 127, and in my case, IP 127 is the IP for A. And now I've landed to 199 as IP B. So finally, even though you don't have a direct internet connectivity, that's a good thing. Nobody or no hacker can directly try to research the security vulnerabilities here. Okay, but as you can first land to A because you know the password, and from A you can log into B because now you can A also know the password of B. We reach here. Now the interesting thing I would like to tell you here is, right, so before I show you, let me again log out from here. Again, I landed to 127 is me A. Okay, and if you notice one interesting thing here, not interesting, but if you notice one small thing here, from the internet I can log into A. Why? Because we have a internet gateway, and internet gateway guys has a DNetting rule or created for us. So from the internet, I can log into A. Okay, that's what I've done. But from the A, if you try to go to internet, for example, I'm trying to go and ping to Google server. Okay, we have this connectivity also. So understand one thing. Okay, by chance, that I haven't discussed yet, but by chance, whenever you create an internet gateway, and whenever you associate any public IP to the instance, they create both the rule for you, SNET and DNET. So from outside, somebody want to connect to you, or if you want to go to outside, okay, both the cases is different. If somebody come in from outside to you, it's called DNET, and if you go to outside, it's called source net. Okay, so when you guys create an internet gateway, okay, they will create both the rule for your instance wherever you apply public IP. Okay, so internet gateway is not only for DNET, it is for both. Especially actually, we used internet gateway for the DNET actually, but they also create a reverse rule for you. Okay, so this is one thing. But if I had log into 199, and from here, if I try to connect to any of the IP on the internet, we don't have a connectivity. We don't have the connectivity. Okay, and that's the guys very important thing. Okay, so technically, what happened, right? What I wanted nobody from the internet can connect to B. That's all we want, because I want extra security. Is called isolation. That's a good thing. But in this case, B also don't have a connectivity to the outside world. Okay, maybe sometimes that's okay, but not most of the times. And one of the good example for this instance, in this instance, I can show you. You don't like that example, means you don't, that is not the right, that B won't have a outside world connectivity. What I mean by this, right? For example, because this B is a Linux operating system, and you guys know, in the Red Hat operating system, if you want to install any software, we have to use yum. And most of the time guys, if you know about anything about the yum, okay, so most of them guys, this is the file we create for the yum. And in this file guys, if you try to open this file, if try to open this file, uh, they have created some rule, and say, if we would like to download the software, we will go to these urls. Means technically they are trying to tell you, if you want to go to internet, sorry, if you want if sorry one minute. So technically what I'm talking about, right? It is very common thing. If you want to install any software, update some security patches, any updates, or maybe this Windows system. So if this is a Windows, they will go to Microsoft. If this is Red Hat, they will go to Red Hat servers. They have satellite or RHN there. So OS to OS, they will go to the respective company to download the latest updates, patches, security update, and these are very common things. And for the security, is always best thing to keep on updating the softwares. Okay, but right now this B computer is running inside the AWS world, and maybe you are Red Hat, then you will go to Red Hat portal to download software. And if you have Windows, you're going to Windows server or software center to download the softwares or updates. But challenge is, guys, right now Red Hat servers or Microsoft server, for these guys are running on the internet. But challenge is, guys, because they don't have an internet connectivity. So how they go and download the software and install the updates? It means it means if I have a requirement, and for example, I would have to install some software here. Let's say I would have to install MySQL, or let's say I would have to install one simple software HTTP. Okay. So for installing this software, or let's say we are updating this software, they will go to internet and download the software. But because this OS don't have internet connectivity, so what happened, what you will see here, they will wait and wait and wait, and after a certain time they will fail. Why are they waiting here? Okay, because this system is trying to go somewhere on this URL, somewhere on the internet, or maybe some Red Hat site, okay, to download the software or maybe updates. And because they don't have an internet connectivity, they can't go out. So obviously they will fail. So after a certain time, you see they will fail. Okay, it's not working. Okay, so my point over here is, my simple point over here is, we want a private subnet. It means, why we want private subnet? That nobody from the outside world can come in. Okay, but sometime but sometime we want the computers from my or system from my instance from my private world, they can go out. And why? This is one of the examples. See guys, finally they fail, they won't work. They fail. Okay, so how we can do this? Okay, so in this scenario guys, you have to go for one more type of router, I can say, one more type of device available in the AWS VPC, I can say, that is called NAT gateway. So for solving this use case, we have to go for NAT gateway. So NAT gateway is the one who will solve this use case for us. Okay, so how we can do this? So setup would be something like this. So file setup guys would be something like this. Very quickly guys, again let me design this diagram again. Okay, very quickly, so you'll understand guys where the network gateway fits. So this is a public subnet. This is a private subnet. Okay, and let's say this is one of the computer. Let's say this is the Red Hat servers on the internet, and we have one computer here. And this computer will want it to go up to a Red Hat server. But challenge is guys, in this private subnet, okay, we don't have a connectivity with the internet gateway. And without the internet gateway guys, we can't go out to the internet. Only public guys has a internet connectivity. So only this guys router has actually internally connected. These guys are not connected, so they don't have a connectivity. But yeah, this company, this private world has their own router. Their router connect to their router. That connectivity we have. Okay, so what can we do? What can we do? We can do one small trick here. The trick is we launch one more router here. First, let me first complete this diagram. That makes more sense then. This one switch we have. We have this connectivity. We have this connectivity. We have this connectivity, and we have this connectivity, and finally we have this connectivity. Okay. So what can we do? What can we do? We can create put one device in the public world. We put one device here in the public world. Why public? The public subnet lab is the only lab that has an internet gateway connectivity. Okay, so let's say we have switch here. So this device, what we are talking about here, this device will be connect to switch. Via switch, we have this router connectivity and we have this connectivity. And what is use of this device? We launched this device or this OS for one specific purpose. The purpose is the purpose is we'll tell this device, okay, if you want to go to internet, can you go? And say yes. They say I can go via this route. I go here, then I go here, then I go here, then I go here. So I'll say my device, do one thing. Okay, do one thing. uh, so somebody over here in this VPC, and you know who is somebody? This is OS B, for example. So B is one of the OS. Okay, what this B will do? Okay, whenever B would like to go to internet, okay, they send the packet to you. For example, the IP of the B, in my case, let's say is 99. Okay, so IP address of my B is 192.168.2.199, for example. Okay, so I'll tell my this device, is device that you are here for providing some functionality or providing some support to computers on the private subnet, let's say B. So if B want to come to internet because they don't have a direct connectivity, so B will come to you. So let's say this is a packet B would like to send to Reddit server or Google or maybe to internet. So this packet they don't send to internet because they don't have connectivity. So this packet from B go to this switch, then this router, then this router, then this switch, and they comes to you. But challenge here is B has a public, so private IP. And second challenge, you also have private IP. So you are inside the private world. But by chance, you are inside the public public network, or public subnet, and public subnet has a facility provided by the internet gateway. What internet gateway will do, internet gateway will assign one more extra IP for you. This is called public IP. Let's internet gateway say the public IP 2.2.2.2, and this public IP they are dedicatedly provided to you, provided to you. So what you do when this packet reach to you, then what you have to do, what a private IP you have. Let's say your private IP would be 192.168, 1 point, let's say 100. Why 1 point? Because you are into the part of public part. So you take the request from B, okay, and you know what kind of request come up. For example, B would like to go to Google. So the packet that that start from the B is like this: that I am 192.168 2.199, and I would like to go to Google. But they take this packet to you. Now, what you have to do, okay, what you have to do, okay, you have to change their IP, the source IP, change the source IP, and update with your IP. What your IP is 192.168 1.100. And you guys know if we change the source IP, then it's called SNet. So technically, we are asking you to do the SNet, source netting. So this device, guys, is especially meant for source netting. And then new packet come up and send this packet again to this switch, to this router, and now this to this router. And when this packet reach to this router say, indicator say from where coming, I'm coming from IP 1.100. And IP 1.100 is a part of public. So this IGW say, I know this IP, and for this IP we have given dedicatedly public IP. So again we do one more time SNet for the public IP and send the request to this guy to internet. And in the same way they will come here, they will send to this device, then again same they go to here. They maintain the internet sessions for all the netting. So maybe two time SNet will happen. One on this device, one is the IGW that they always do for you whenever packet go out. Okay, but here guys, if you see here, for this guy, okay, intention is nobody from outside world can come, or nobody from outside world can initiate the request, because we don't know from outside world who will come. But anytime if internal guys want to go out, they can go out. So nobody can come in, but these guys can go out to internet. For this you have to use this device, and this device should have a facility for SNet. Okay, and that is the reason, guys, this device is one of the special device provided in the AWS, and by chance this device is known as NAT gateway. Technically they are giving the facility of SNet, but actually they are knowing as NAT gateway. Okay, so if you want anybody from the private world can go out to the internet, then you have to provide NAT gateway to those guys. Okay, that's what, guys, the use of NAT gateway. But this device is actually like a router, but they are only for one purpose. So we don't use the word router here, we use the word called NAT gateway. Or you can think, guys, this device is actually the device that you have in your home, that is your modem and the router. Your home modem and router also give you same facility of SNet, and in my initial class I have discussed those part to you. Okay, and why, guys, I explain you in this way, because it is also to know whenever you launch the NAT gateway, it will launch only in the public network or public subnet, otherwise it won't work. Because you might have multiple subnets or labs. So if you launch a NAT gateway, it's like a device, okay, you have to launch only in public, because if you don't launch in the public, they will don't have an internet gateway connectivity. So this diagram also, guys, explain you this concept. Otherwise I've seen a lot of guys are confused why we're launching here. Sometimes they launch private world. So that so I try to explain you guys in very depth why they launch. And guys, again, believe me, read any of the Google Amazon document tutorials, nobody talk about so much in depth about uh, uh, every connectivity, though you won't see this kind of diagram anywhere. Okay, so every bit I explain you internal level about this these connectivity. Okay, so let me, guys, go and show you how we can get the NAT gateway. For this, I've again go to VPC, and now if you see, guys, here I don't have NAT gateway, 0. Okay, so if you want to get a go for net gateway, there's option called net gateway. Okay, net gateway. So, and if you want to create net gateway, just go and click here. Okay, I think guys, net gateway is not a free service. I'm not pretty sure, but I believe net gateway is not a free service. But even though I suggest, just go and check the document of the AWS free tier. So does net gateway come in the free tier or not? Just go and check. Sometimes they keep on changing, but I suggest just go and check. Net gateway is come in the free tier or not. Okay. So I click here. Okay, and here they're asking you. So let's say this is my Linux World Net Gateway. Okay, so that's what we give the name. But the most important thing is subnet. Even though they are very much clear nowadays, but sometimes we don't read. But some time ago, they don't write this kind of statement. So they say a net gateway, whatever you put, it should be a part of some public subnet. So in my case, I have multiple subnets, but you have to select the public subnet. So in my case, the lab number one is a part of public subnet. So I select this one. Okay, select this one. And one more interesting thing, if you see here, you have to allocate a IP address to the net gateway. Assign or this elastic guys in the AWS public IP is also known as elastic IP due to some reason. But whenever you see elastic IP or EIP, that is equals to a public IP. Okay, so when you see EIP, Scholastic IP, it is equals to a public IP. And what actually is talking about, whenever you are going to use this device here, you have to allocate the public IP. And technically, internally, they're talking about you have to go to IGW and assign one public IP and create some SNetting rule. So this actually what's actually technically they're talking about. But yeah, we can't go and see where they're allocated, but this is a way actually they have done for us. So they're asking you to assign the public IP. So I don't have any public IP, public IP. So you can allocate the public IP. Okay, how we can allocate? Just click here. They will auto allocate the public IP for you. And again, one thing, EIP service is also not free. Whenever you yourself allocate public IP, they will come with extra cost per month or per some time they charge you. Okay, so if you want to do this practical, they will charge you very little some amount. Just test it, just close the services. So some charge they might charge from your free tier. Okay, and that's all, and finally it's done. So they are creating a new device for you known as known as net gateway. Okay, they're still pending because technically they are spawning one OS or one kind of device to you and doing all the further things for us. But if we talk about this net gateway, so this net gateway, I told you guys this network gateway is a part of your public network. That is the reason, guys, they give a IP of this network gateway is 1 point something. 1 point means they are put inside your public subnet. But they put in the public subnet, but why this net gateway come up? To provide a facility or services to the private guys. So private guys will go out with the help of these guys. Okay, so this is one thing, otherwise nothing very special here. Let me refresh this page, so they might come up again, still pending, but yeah, in some minute or second they will come up. After they come up, what I'm expecting here from this net gateway, now if this OS want to go out, nobody can come in, that for sure. For this you require this connectivity, you require a DNAT rule, you require public IP to this guy, that aside to this later. This is not there, so nobody can come in. But this OS want to go out, like from your laptop in your home you can go out, but nobody from the internet they can come in. Okay, so I expecting this to go IP go out. Okay, so I'm just waiting for net gateway to spawn for us. Let's see. Yeah, so it is available, and as soon they're available, they also have a EIP, or I can say the public IP. Okay, but technically it look like this public IP assigned to internet device, but internally actually they assigned to again the network card of IGW. But look like the way I explained you yesterday also. Okay, now let's go to the same instance. So I can't directly connect to go there. So let me connect to my bashing host A, and from the A I can go to B, so I can show you this practical. And from here, so let me do SSH. Okay, to IP 1 9, and the last time, guys, I tried to ping to A 1 8, so 199. I'm trying to go out to the internet. Last time it was fail. Let's see this time again they fail, or we have to do something. Again, guys, they fail. They fail. They are not going out. Even they say the 8 packet transmit, 0 received, they're not going out. Okay, so again there is we are not achieve this thing. And why we not achieve this? So it is the similar concept why what I explained you yesterday. Okay, the concept was right when this OS B want to go to internet. For this OS they want to go to 8.8, means to different network. And because you want to go to different network, so packet will reach to their router of lab number 2 or private network. Their router. And this router say, okay, I will take you out to the internet, but challenge is I challenge is I am a router, and router has my own routing table. And in my routing table I don't see any rule that help me to decide which path to use. I don't know how to go here because I don't have wires. There's no meaning to go here, but I don't know how to go here and further thing. So I don't have any routing table that will tell me, right, if you want to go to intent means if you want to go to 0.0.0.0, what would be my next router. Okay, the way I explained here also. Yesterday, guys, I update my routing table over here and say if you want to go anywhere in the world, for you the routing table is this one, or next router is this one, or next technical call hop is this one. So for the router, guys, if the router want to go to next router, that's called next hop. Okay, but for this router of the private, they don't know if they want to go anywhere in the world or square internet. So they don't have this route. So what I mean by this, if I again go to VPC and if I again ask the subnet number 2, if I click here and if I ask the subnet to you have connected to one routing table, and if I ask the routing table, do you know how to go out? So this routing table say no, I don't know. There's no rule route for 0.0. I can just can travel from within the network, within the VPC, one lab to other labs, one subnet to other subnet, but I don't know how to go out. So we have to update this routing table. But I told you guys it's good practice not to update this routing table because this routing table may be used by other labs also. By chance we have only 2 labs, but we might have more subnets in this VPC. So it's always good practice to create a different routing table. Okay, so I'm going to create a different routing table. Let's say the name is Linux World routing table for net gateway. Gateway, something like that. And this routing table is a part of my VPC. That's all. So routing table has been created. It's just a name. When I click in this routing table, so this routing will say I have a routing table rule. And this will because I'm part of your VPC. So I know in your VPC, anywhere you want to go, I can go. But I say I want some more thing from you. So can you please edit the route? And can you add one more route? And I would like to say to this routing table, I'm going to create a rule for everyone, anybody in the internet. So if you want to go, if somebody use you and they want to go to anywhere in the world, then the target for you is the not the internet gateway, okay, is the net gateway. So guys, if you go and select the target, you will see the net gateway name come here. Yesterday we used internet gateway. Okay, today we are going to use net gateway. Why? Because to solve this use case, and one of the reason is because finally we are going to apply this routing table here, and they don't have a connectivity to internet gateway, so there is no meaning to use the internet gateway. Only this guy has a connectivity with the net gateway via this route. Okay, so I'm asking to use only net gateway. And guys, automatically the net gateway name you have created automatically come up. That's all. So it's been created. That's all. And I've had asked this routing table. Now this routing table say I can go anywhere in the world by the help of net gateway. But this is the new routing table we have created. In this routing table, none of the subnet or lab has associated. There is no name here. There's no one associated. It means, okay, none of the lab routers are using this routing table. But I want my private private lab router will use this routing table. So for this, I'll go to my subnet 2, and here I say subnet 2, you are using this routing table, but I want you, can you please update, edit. Don't use this routing table because this routing table don't know where the net gateway is. So update this routing table with the new one for net gateway one. Okay, that's all. And guys, what you'll see here, you'll see here this rule come up. And finally, save. That's all. Okay. Now, interesting thing is, interesting thing is, if you again go to this subnet, again, this is the same subnet where this is my same subnet that's running as a private, and in this subnet, one OS is running. There's only 250 IP is available. One OS is running. Okay, this is B. Interesting thing is because this subnet, or I can say this subnet router has this routing table, and they know how to go out now with the help of this device. Which device? This device. Help of this particular device. Okay. Now in this case, now if B want to go out, okay. So let's see what happened. So I don't know. They again always hang the browser if you don't use for some time. Let me connect again. So again, this is A. I log into B. Okay. Now B want to go out. So guys, till date, we have seen they don't have a internet connectivity. Okay. But before this, let me show you one interesting thing. Okay. If I go to my instances, right now, guys, if I go to my instance number B, okay, they are running, but they don't have a public IP. Even though without having the public IP, they can go out because they don't have a public IP. Nobody can come in directly. But these guys don't have a public IP, even though they can go out, because here they are using the public IP of the net gateway. Now if I write to ping, you can see it's pinging perfectly. There is no challenge. So anything, maybe this is a Red system. Now if I wanted to use the yum command to install some software, you can install, because yum command will download software from the internet, or maybe from the Reddit side, or maybe some other location. Because they have the internet connectivity, they can run. Right now this command failed. You should record root. Either you have to log in with root, or you can use sudo command in the front. They will give the root power. Now guys, this is working great, right? There's no error come up. You can install software, download and install for us. So interesting thing, and the beautiful thing is nobody from the internet can reach to B. So as a hacker, they never know a public IP or private IP. They never reach to you. Even though they know IP, they can't reach because they know there is no direct connectivity. But B can go out to the internet. If this is a requirement, and this is a very common requirement, especially in the private world, okay, and this same kind of infrastructure I've set up, you have in your home. So you can think B is your laptop in your home, okay, and nobody from internet can come to your system, and your laptop has a private IP right now, even though you can go out. Why? Because in your home you have a SNet, you have a net gateway. That's your router or maybe your mobile hotspot. Okay, so you can think this same kind of setup. But why we have to use, I explained you already. So guys, this is one of the great practical about net gateway. So multiple different gateway I explained you. Internet gateway have different use case. Net gateway has a different use case. Okay, there's some inter routers. They are not showing you, but there is. I show you some way, somehow yesterday with some kind of route command. So they also have this router available. Okay, so this is a very typical design and very commonly used design or architecture or topology we use. Okay, so let's discuss some more thing here, guys. Some more basic concepts here. Okay, so very small concept, guys, but maybe useful. Okay, so one small concept here is, okay, when now guys, now it your choice. Okay, you're going to launch one new instance, a new instance. Sorry, you're going to launch one new instance. Okay, now you have to think this particular new instance, you want to make it public or private. So accordingly, you can put your computer on lab 1 or lab 2. So that's how you think. So click here and click here, and here you decide in your VPC, put in B, it make private. If you go to A, it make public. But if you notice one thing, because our intention is to make this OS public, in public we need a public IP. By the way, guys, if you see, auto assigning is disabled, so you have to always go and manually enable this. Okay, because I want this OS has a outside world connectivity. So if you want, if you want, whenever I launch anything in lab 1, my auto assigning IP with automatic enable. They don't go for disable. They will automatically enable. Okay, if you can enable manual, that's a different point. Okay, but I want auto assigning. I don't have to select. They will come, not disable, enable. So for this, guys, there's small setting you can do in your VPC. So if you go to your VPC, this is VPC we have, and we click in your VPC. In your VPC, guys, in the top of your action, okay, there's a and actually not in the VPC actually, because we are doing this thing on your subnet. Okay, so you have to go to your subnet actually, because we are launching on the subnet number 1. Go to subnet, and in the subnet, if you go to action over here, and there's option called modify auto IP assigning setting. Okay, and might not be so much useful, but guys, when you go for automation, okay, so maybe you use Ansible or AWS command or Terraform, and we know whenever I would deploy any OS in the lab 1, I want public IP to assign. So we have to add some extra parameter for this. I give IP, don't give IP. But if we always need an IP, so enable this option only once. So whenever you launch the OS again and again, you don't have to write some extra parameter in the command line to enable the IP. So there also, this part will be useful. So technically, it just go enable, that's all. So nothing special, but sometime it is beneficial. Okay. So now what happened? So I go back to this page again. Let me go previous. And then this time you'll see some small difference. Just go to configure. And as soon as I select lab 1, automatic, this will come enable. They are not coming because I think I have to again go to this page. So I think it is enabled, right? Let me check one more time. Modify auto IP settings. Enable auto assign public IP address. Yes, it is enabled. So select. Small settings, but useful settings. Yeah, if you see, guys, here, so in default also, guys, they had this setting enable, default network that they had. But in our network, if you go to VPC, B is obviously IP disabled because B don't provide a public IP. But if you go to A, I see automate enable come up. So maybe in the web UI is not so much important, but if you go to automation command lines, this setup maximum time is very useful. Okay, let me guys give one more information here. Whenever you guys launch any instance here, for example, I launch instance in 1A. Okay, so guys, normally till date, I don't know have you noticed or not, right? Till date, whenever you launch any instance in your VPC, at the default VPC, they always give public IP. Okay, but every IP, guys, they give you a name. It's called host name. It's called DNS app. But here they doesn't give me. Okay, but till date, guys, if you notice, guys, if you launch any instance in your public world, they give public IP plus they also give a name. It's called this called DNS name. Like, for Google, they give www.google.com. Okay, that's kind of a DNS name. Okay, so this is the by default nature when you create your own VPC and subnet. Okay, but if you want in this VPC, whenever I launch any instance and that instance have public IP, so automatically gives some unique host name or DNS name. So for anybody in the world, either can use the public IP or the DNS name. Okay, so for this, okay, so if you go to subnet, so there's no option in the subnet for this because this is setting we have to uh, do for our VPC. So there's my VPC. So if you go to this your VPC and in the VPC, if you see here also here, DNS host name feature is disabled. There's a by default nature. But if you go here and there's option called DNS resolution. And guys, it's very important feature. If right now it's not so much important, but if you don't have this feature enabled in this VPC, or in the future, there's some services, okay, you will use in the future that require they don't work in the public IP. They need a public DNS name or public host name. Okay, so I'll show you some service in the future. And if your VPC don't provide a DNS name or public DNS name, that service will fail directly. They fail. Okay, that's very important to know. Okay, so that time, because we are working on that services. So if something fail, we don't focus and we keep on checking and troubleshooting those services. It never come in the mind there might be issue in the VPC. So that's the thing I'm telling you here right now. So it's always good practice while creating the VPC, enable that feature. Um, edit, sorry, edit DNS hostname feature. Okay. So when you click enable, that's all. That's the only thing you have to do. So now from onward, whenever you launch any new OS, okay, in this VPC, and if this OS has a public IP, and that's one thing, guys, we can assign public IP to private computers also. Technically, they don't have physical connectivity, but we can provide. So any system that has a private public IP come up, they will give a unique host name for the internet, like www.google.com, something like this. That we can change also. How we can change? We're using service called Route 53 DNS service that we'll discuss in the future. Okay. So anybody, any new system come up, or maybe right now, guys, if you refresh, automatically also come up, right? So nowadays, guys, they have given this facility, but initially, so long ago, you restart or uh, a new system they will give you. But here they give you one unique IP, unique name. So the public IP and this is a unique host name or FQDN also you can say, fully qualified for domain name provider to you. So anybody in the internet, because it's a public one, so they can use, for example, for my laptop, my Windows, if I try to ping to this guy, I will have a connectivity. And if you notice also, this name first convert to the IP address, same IP, and then we have a connectivity. Okay, but yeah, maybe you might see, I don't like this bigger name. I have to give the name like www.wiml.com. So we can also do those things. I'll show you when I go for Route 53. Okay. So likewise, guys, there is a small settings here, maybe useful, but we will see in my future classes. Maybe it's flow logs and other things also might be useful. In the DSCP, this might not be useful. Let me check if we can discuss a little bit here. Right now is not useful, but I was talking about your labs always has a DSCP server, so something we can configure here. Okay, what something right now we don't require, but whenever need in the future we'll discuss. So a lot of things we talk about VPC. But let me tell you one more interesting feature from the AWS that I technically don't like, but a lot of guys use. Okay, so guys, if you guys notice the VPC, lots of things we have to create. If you guys see this entire infrastructure we have created, VPC, two subnets, one private, one public, one internet gateway, or one net gateway. So this structure is plus routing table attached. Lots of things you have done right here. So this is a very typical, commonly used use cases. We use this infrastructure, or because this is very common. Okay. So what Amazon has given in the VPC, they given us pre-created program. So they say one click, the entire structure or infrastructure created for you. So they given the name called wizard. So they given us one wizard to create this kind of use case. So if you go to your VPC dashboard, okay, and if you see guys here in the top, the launch a VPC wizard. Okay, so technically they say just one click, the entire setup, whatever did from last 3 days, they will do in one single click. So if I click here, um, and why I don't like this wizard, because these are pre-defined. If you want to have any customization on it, because normally in the real world we have to customize according to requirement, we can't do much, I can say. So this is, guys, I haven't used this wizard. Otherwise this topic can be complete in 10 minutes also. Okay, so my intention was to explain every bit, so I just go to this long path so that I can explain every bit of it. But they show you we have the 4 different use cases. So if you need only one single subnet, this is the diagram they created. So one VPC you create, one public subnet you create, and so that anybody from outside world can then connect to you. So if you want one single public, no private, no net gateway, just click select and we will create the setup for you. But if your use case is VPC with public private, and guys, this is the exact setup we have done. So one VPC, one private, one public, one net, and they have inter gateway also. So if you want all those settings, okay, just click here, and I will create for you. Obviously, after you click, they will only ask you one single thing: give me your network range, which IP range you want to use. That's all. Otherwise, just one click, they will do those things for you. Or maybe VPC guys also have a setup of VPNs. So if you have some kind of corporate VPNs setup for IPsec or maybe something else. Okay, so just one click, they will create for you. So maybe guys, I'll try to touch VPN part also in the future classes. Normally in the security of AWS we cover in depth, but I'll definitely try to touch VPN. Okay, so these are the guys. So this is called wizards. I'm not showing you, but if you want to click or quickly create the entire setup, that's the one great way to do it. And one last topic for today is NACL, right? NACL. So what is NACL? So guys, now because you guys are very much comfortable with security group that is equals to firewall. So NACL is also a kind of firewall. Firewall. Okay. Or you can think NACL is something like a security group only. There's small difference, but it's something like a security group. Okay. But the placing would be a little bit in the different place. What I mean by this. So again, guys, till now our setup is like this. Okay, in this setup we have a two rooms, lab subnets, lab 1, lab 2, and in this subnet we have we have maybe let's say we have multiple OS. This is the OS number A, this is OS number B, or maybe C. Okay, and you guys know whenever you launch OS from EC2 always give a security group of firewall. Okay, so before this, just before the OS, they put one security group here. Before this OS, they put their personal security group here, and before the C, they put their own personal security group. So let's say A is my web server. So A can write in their security group that anybody who want to come in, allow this guy only for port number 80. Or let's say B is the meal server. So B write anybody who want to come on port number 25 that work on SMT mail server, allow it this guy. Or maybe C for other things. But maybe everybody has to write, if somebody want to ping us, don't allow. So ping, not allow. Ping, not allow. Ping, not allow. Okay. So what can we do, guys? Maybe in this lab, maybe public or private is not important, but in this lab, if you want to create a rule that is common for all, okay, common for all. So rather than you go for every security group, okay, we can do one more thing, because we know, guys, these guys are kind of one switches, and switch is kind of router, and there's only way to come in, go out is the router, a router of this lab. So what can we do? We can do one more thing. We can also place one more common firewall over here. Okay, and we can say if anybody come in for ping inside any of the computer, don't allow. So it's one common firewall for the entire lab, entire subnet. Okay. Or like this, we can create some more rules. Or we can create one more rule. For example, there might be one more computer here. Let's say computer E. So we can see in the firewall, if E come, obviously they have some IP address, and try to go inside this lab, don't allow. Okay. So this kind of things we can do. So technically we are controlling the entire network. Okay, entire network. So we are controlling who can access the entire network, guys. Normally your security groups normally is applied per OS. Normally we can apply same security on other OS, also a different point, but normally security group apply per OS. So you can think security is like a small firewall per OS basis. Okay, but this firewall is applied for entire network access and the control the entire network. And here we have to create a rules also called list. So it's called like network access control list. So there's a big difference, guys, between the NACL and security group. But NACL gives a little bit more extra options. There's a different point, but the bigger difference is the why that I explained to you. And that is the reason, guys, because we normally create subnet or lab in the VPC portal. So if you want to use, if you want to use, sorry, and NACL, you have to go to VPC page, and over here, if you go down, we have security group and NACL. And get this security group is exactly the same security group what you see in your EC2 page. So all the security group you create here in EC2 portal, same, widget 5, widget 2, widget 5, widget 2, same come up here. So this page is by chance is same because security group same. Okay. But in the EC2 portal, I don't have any NACL page. But if you go here, we have NACL, network access control list. Okay. And now here we can create a NACL. Okay. By default, guys, in our VPC, we have two subnet we have created and one NACL rule already created for us. And this NACL rule, guys, say, you guys know what inbound and outbound, right? You guys know. Okay. So this inbound say that anybody from anywhere in the world come to any of the port and protocol that is allowed. So by the firewall is already established, guys, here. Okay. But by default rule is allow all the guys. That is, guys, this firewall is not in effect till now. Till now. Okay. So, but if you change some rule here, I told you guys rather you change the rule because by chance this NACL or same firewall is also applied here also. in this lab also. So if you see here, this firewall associated with the two subnet. So if we change any rule for the lab 2, this will also affect in lab 1 also. Obviously guys, for lab to lab the rule will always change. So it's all like a routing table, right? So it is always good practice to create your own personal NACL. So I'm going to create a new NACL here. Let's say this is the NACL for lab 2 for Linux world, and this would be inside my VPC. So it means, you purchase new firewall device and put in your company. It is something like this. This is created. Okay. But if you see here, guys, here, this only the firewall we purchase is not associated to any of the labs. So it means you create any of the rule in this firewall. So let's say new firewall device we purchase, but this is not connected to this lab, neither this lab. So whatever rule you create, it won't in effect. Okay, so it's empty. Now, if you go, see the description of this, this is not associated. Okay, but why you create this? Why you create this firewall? Like I would like to associate this firewall to one of my lab. So I go to subnet association, I click on edit association here. Okay, and I would like to connect to lab number 2. That's all. I selected, and this name come up, and that's all. I did it. So now this firewall is connected to this subnet. So if I again go to NACL, okay, now this NACL, now this NACL is connected to the subnet. And guys, if you notice, guys, in my last NACL, there was 2 subnet. Automatically, guys, become one, because it is something like this. Okay, as soon as you connect this new firewall to lab number 2, older firewall automatically removed. Now this older firewall is only connected to the lab 1 because we have an edited lab 1. This is one thing, right? So now it means whatever we have in this NACL as a rule or firewall as a rule, it can be effective on the lab number 2 because we are connected to lab number 2. Okay, and what rule we have by default? So you see the inbound rule. Okay, so by default the rule, guys, in your NACL, whenever you create a new NACL, is when anybody from anywhere come for any other protocol, everything is denied. Everything is denied. It means anybody from anywhere in the world come in, maybe from local lab, from outside. Obviously, outside world we don't have the connectivity, but anybody try to come in, nobody can come. It means if I again go to my uh, instances, or I'm going to instance number A because we don't have that connectivity. So I'm guys connecting to instance number A of lab 1. And guys, till now from the lab 1, if I try to connect to lab 2 instances, maybe ping or SSS, we have a connectivity. But now, guys, we don't have a connectivity. Stop. Because from lab 1, we are trying to go to lab 2, and lab 2 has one firewall, let's call network firewall. They're not trying to allow me to go to their network or LAN or subnet. We can do ping, we can do SS, nothing is allowed. But if you want to allow this part, so I just go to inbound, edit the rule, add a new rule, and we say anybody who want to ping anywhere in the world, allow this. And one interesting thing is if you compare with NACL or security group, in security group, guys, there is no option available to choose allow or deny. Okay, by default in the security group, everything get deny. Any of the rule that you keep on creating is allow. But by chance, guys, they have a option to allow somebody or to deny somebody. So I can create some customer rule. This IP allow, other IP deny for ping. So those kind of customized rule we can create here. There's a extra thing. And every rule, guys, we have to give a number. Okay. So let me give some random number 10 here. So what the use of this number, I will explain you. Okay. Let me save it. So now in this firewall, NACL, one rule come up. Okay. And the rule say anybody from anywhere in the world try to ping, allow it. Okay. So if I again go and try to do SSS, is not allowed. But if I try to ping, it is it is allowed. Okay. So it is not allowed, guys. Ping. Why? There might be one reason why they not allow ping, because of the outbound rule. Maybe because of the outbound rule. Okay. What I mean by this, pretty straightforward. Pretty straightforward. Um, uh, uh, if this is the one computer, let's say A, and this is one computer, let's say B. Okay. And between we have firewall. Okay. And if A want to ping to B, B to B, so A send a packet, it go via this firewall. Because packet is coming from outside, it's called inbound rule. Somebody coming from outside, it's called inbound or ingress. Okay. And then firewall say, for inbound, because you're coming for the ping or ICMP, we allow and send to B. But guys, when I say ping or connectivity, right, this is only the request. B also have to reply. So B will also create a packet, and this packet will go via firewall to the A. But because packet is going out, because they come from B as a reply, they're going out of this firewall. So for this firewall, this packet is called outbound packet, outbound traffic. Okay. And if you see here, if you see here, the outbound say everything wherever you're going. See guys, a destination. So wherever you're going, for any of the protocol rule or commands is denied. Okay. So, so we have to create one more rule here, outbound, and see if you want to go uh, anywhere in the world, destination is not source. In inbound, you see source in the destination. Okay. Only for ICMP we are allowing. And just give some numbers here. What use of the number I will explain you. Okay. And let me save. So in this firewall, let's say anybody from anywhere in the world come in for ping, allow. And if you want to go out anywhere, as maybe reply, or maybe you want to ping to others, maybe in this case also, that's also allowed. And now if I go and try to ping, it's pinging. Great, right? Now, guys, there's one interesting thing. I don't want to go to deck Dexter right now. Yeah, SS you can do. Okay, but guys, there's two main different kind of firewall available in the market. Okay, one firewall is called stateless firewall, and one is called stateful firewall. What I mean by this? Okay, I'm not going to explain in detail, but I just want to give some vocabulary here, because there's some beautiful thing of the firewall is, okay, you know what happened if A want to ping to B. Okay, and in between normally we have the firewall. Okay, and in the firewall, let's say this is IP1 and this is IP2, and the firewall A want to ping to B. So A is coming, and this firewall belongs to B. So B firewall say somebody coming in, somebody coming in. I can give one different example here that makes more logical sense. So let's say A has their own personal firewall. This firewall belong to A. Or in the A, guys, we create a rule. If any packet go out from this firewall, from the A. So according to firewall, this packet is called outbound traffic. Okay. Allow everything. Allow everything. So A create a packet, send. Firewall say because you're sending out, we allow. They go to B, and B will reply. But you know what, guys? Because B packet is coming in, it's called inbound. But this firewall say, in my inbound, everything is denied. I don't allow anything. It means if A go to Facebook and Facebook reply, technically A packet go to Facebook, but when Facebook reply or Google reply, the firewall say, I'm not allowing you because nobody from outside can come in. So in this case, guys, A won't able, even though A allow to go out, but none of the traffic will come back because firewall deny. because inbound say we're not allowing any inbound outside traffic in coming in. Okay, so it means A won't able to see any of the data from Facebook or Google. Okay, so here guys, the beautiful thing about the firewall, some of the firewall is, right, they're very smart. Okay, what they do, technically inbound rule is denying everything. Okay, but what the firewall do, whenever A want to go to B, obviously B will always reply. So we know what the firewall do. Firewall dynamically create a one rule for the B and say when A send a packet to B, and in this process, if B reply with some packet, that's called in this session. For this, only for this packet if B reply, that's called session. Okay. So with even though we have the rule, or if you don't have the rule, allow B. Let the B come in. Let the B come in. That kind of firewall is known as stateful firewall. They maintain the session or they maintain the state. Okay, don't want to discuss this part in detail. Maybe in security part, we sometime we discuss in very detail. I would like to best explain you. So that is guys. If you go to your laptop firewalls or Windows firewall, normally those firewall are straightforward. So if Facebook try to come in your laptop directly, they can't, even though if you have public IP. Okay, because technically your firewall or Windows and your Red Hat systems or whatever you have in the OS, uh, they say anybody try to come in, I won't allow. But if you go to Facebook, you will get the packet from the Facebook. That part will allow by a firewall. So dynamic they create the state for you is called stateful. So why I'm explaining this point to you, because this outbound concept we don't require in my security group. That's also firewall. But my security group say uh, if I go out, automatically create for rule for inbound or outbound. That's what they said. So I can say my security group firewall are using the feature of stateful, and NACL, right, don't maintain the state or session, right. We have to write both the rule in both the side. It's called stateless. Okay, we have to create the rule for both the sides. So if you send a packet to B, if I will say I allow A to B because you're going out, but if B reply to you, I won't allow you to create a separate rule for B also for inbound and outbound. That's what we have done in the NACL. So there's a small difference in the terms of technological perspective in security group and the NACL. So here we have to create a rule for both the sides. But in the security group, they dynamically create the rule for us. Okay, and this is one thing. And one more small thing, why we give this number here, this is the priority. Priority means, for example, if I go to inbound rule, if I create one more rule here, and here I'm again allowing ICMP only for some, let's say, IP address, this one. Okay, and I would have to deny only this IP, so I can deny it, right? And one more thing, guys, if you want to use any source, you have to give a net mask. And if you want to give only one IP, the net mask for one IP is slash 32. That's 32. So if you don't want to give the network or network range, if you only want to give only one single IP, the net mask of one single IP. Okay, that this I am just giving one single IP to do something. This called slash 32. Okay, and here, guys, if I give some number, let's say 25. Okay, you know what I mean by this? What happened? What happened? So if you see here, what happened? I'm so sorry, guys. I edited. Actually, I have to add the rule. Let me add the rule again, the older one. What I'm talking about, just give me a minute. I will explain you. Okay, so guys, this is a rule we had. Now, according to rule, what I wanted, I wanted to allow all the IP in the world allow to do ICMP ping. But I wanted to only deny this IP. They won't able to ping me. But guys, in this rule, okay, in this rule, this line never check. And if any packet come from this IP also, they also allow. Technically, what I mean by this, right? It means, guys, whenever you create a rule, every rule we have to give some number, and number give the priority to this rule. So number 1, 2, 3, 4. One has more priority, two has second priority. So 10 means this rule always read first. So it means any packet come from IP 2.2.2.2. This rule check, are you belong to this range? Yes. So you are allowed for ping. Then any packet come from 1.2.3.4. They can check, are you coming from this range? Yes. For ping, yes, we allowed. Okay. Or because because they allowed, or I can say the pattern match, they never go to second rule. As from the pattern match or rule match, they never go there. And because they never get go to a second line, so they have never checked that you are denied. Okay. And that is the reason, guys, right? If you want to specify rule for some smaller thing, okay, you want this rule always check first. So you'd always give the rule number lesser than this. It is something like this. Just give the number 5. Now, this rule check first. So anybody come from 2.2.2? Does this rule match? No. Then they go to second rule. Right? Does this rule match for 2.2 to IP? Yes. So they will allow. But any packet come from IP 1.2.34? Yes. This rule match for ping? Yes. They will deny. And they actually deny, they won't go to next rule. So guys, any firewall in the world, maybe Linux IP tables, or maybe Cisco has ASA firewall, any firewall in the world work in the same way. They just keep on checking the rule one by one. Wherever the rule hit, they will either allow or deny. It's called target. They will do for us. Okay. So guys, that much knowledge we don't require in a CSA level training. If you go to some network security trainings, so this concept we discuss there a lot, but I try to explain, guys, as much as I can. Okay. So so that is a main thing here. So that's all, guys, for today. Lots of concepts of NACL, plus use cases, plus practical implements I explain you, plus we have seen net gateway also. So that's all, guys, for today. Next class will be next Saturday with some more new concept. VPC, we have some more discussion, right? As and when required, we keep on coming. Maybe VPC peering or maybe some other concept we will keep on discussing in the future classes. Okay. So any queries, if you have, guys, you can ask me. When you will start machine learning again? No plan, Archieman, no plan. Some kind on Node.js, Java, AWS. Pradeep, we will cover all the things in the Earth. If you're the part of Earth, right? We cover Node also, Java also, AWS. We are discussing. Yes, Gagan. I guys highly recommend all of you guys over here. The entire setup or the entire this infrastructure, what you see here, I highly suggest if you can do with the AWS command line. First, do with the practical with the GUI, then do with the CLI. How to ping particular user in the Ansible on the top of it. Mayank, we don't ping user. We always ping the OS. Ping is done to the OS, right? There's no meaning to ping to the user. For the to the user, we log in. So we can disable the login, enable the login. There's different point, but we don't ping user. Using route can be blocked by IP. No, Wagila, a route is used to tell you what is the path to reach there. Route is not to block, but obviously, guys, if route doesn't guide me where the path is, technically it look like it block. Okay, so for example, I want to go from Delhi to Mumbai, and the road you have signboard. The signboard is called route or path they are giving you. But if you remove the signboard from there, so technically it's not block, but it look like block because we don't know where to go. So fine, it look like block. So the answer is Wagela. Using the route, we don't block, but we can somehow block the things. So why which adapter is not working in the OS? It is working, sis, which OS I'm talking about. I don't know which OS you're talking about. My code is sitting on the on premises and database in AWS. Hemant, I'm not reading this question right now, but this kind of scenarios we have uh, a lot of discussion we have in this kind of scenario. So when I start with the RDS services in AWS, so we will discuss this kind of scenario a lot there. Just wait for some more days. I think what are you asking will be covered. How incognito work behind it. Incognito, guys, or Ronak, it doesn't maintain store your cookies or sessions permanent in your browser. uh, Nagaranjan, we can do the same thing with internet gateway also, but it is, sometime if you create a multiple different service, every service are doing their responsibility, so it's very always simpler to manage. So that is the reason, guys, they have created one extra service or device for us called net gateway. So it's very clean and simple to manage. Very easily we can go and plug and play the things, right? That is the main reason. Why we don't get the yum packet written download? Because there's still maybe you're asking this yum packet question related to firewall, because there I was using security group, and security group say if we are going out and my firewall is allowing me to go out, so any return traffic we won't check the firewall. By default firewall will allow me. Okay, that is a by default nature of the security group, and that is called stateful firewall. So, Abhishek, mostly AWS written the entire code, or mainly all the service AWS is running on the top of Linux. Almost all the services. Ansika, FQDN is fully qualified domain name. So technically, www.google.com. Sometimes it's a host name or domain name, but technically in the right form, it is known as fully qualified domain name. Even the full name of the www is www.google.com. If you write the dot also in the last, that means fully qualified domain name. And dot has a meaning also, right? Maybe when we discuss more depth somewhere in the DNS, I will explain you. I think, Pradeep, you're talking about Kubernetes training, right? Right. So if you want, mm, we'll discuss, maybe if you want, maybe last class, I will explain you what exactly we are going to discuss. Rohan, we already started DSA, right? We discussed multiple things, but yeah, we keep on discussing from my next week. Okay. So can we have sometime net gateway? Oh, yes, yes. Sobit, you will have net gateway also in your virtual machine. Okay. And one quick thing, guys, by default, your Oracle virtual box has net gateway already associated. So guys, when you do right click and go to settings, in the setting, guys, right now I'm using a network called Breeze. But if you see here, there's an option called net. This net is actually equals to net gateway. Okay, so by default all the virtual softwares provided you a net gateway. Net gateway is a term from AWS, but technically is not this concept is called netting or source netting. So answer is yes. They have. And even though we install any new OS in the virtual box, by default your by default network adapter is net. And that is the reason, guys, you can go out to the internet, but your IP never go out. You will use the IP of your base system, and base system will convert the IP of your broadband. So that's the point, Sobit, you asked me. So, Saurabh, if you use your mobile phone with a SIM card, your router is the router of your uh, first ISP. So your ISP has the router that will give you further connectivity. Does all like public subnet will be different? Yes, Maharshi, it should be different because obviously public subnet and private subnet. So I think you asked me, does all the IP in public subnet will have a different public? Obviously, if you're on the same LAN, you should have. It's not compulsory. You can give all system has same IP. That's also work. Not work, but you can give. But there are a lot of network connectivity issues come up. So obviously you should have a different IPs. Public IPs also and private IP also. But there's a way in the networking concept. Maybe this concept I will explain you if you guys might be part of Kubernetes training. So there's one more type of netting called P netting, port netting. So you don't have to give public IP for per system. So we will give one public IP to the router and hundreds of computers we can connect in the private world with some one single public IP. The concept called padding, port address translation. So um, when do you security group routing table in NACL? Suvam, don't worry, guys. I'm not asking you to just in one day to comfortable with your topic. This concept will come multiple times, hundreds of times. You become comfortable. Okay. Abhijit, asterisk means the last rule. Explicit rule. If none of the rule match, the final rule. Uh, what is the final rule? The asterisk is the one who will tell this is the final rule to match. Oh, that's nice, Milind. You have passed the Genk exam. It's good, right? It's great. It's a great exam. Congrats from my side. So, guys, there's a lot of questions, but I feel if you uh, um, if you guys practice this, you will get a lot of new idea, right? VPC, most of the topic in VPC is complete, but not all. Don't worry, we will have some more discussion on VPC. Okay, so that's all, guys. Uh, for today, we'll see you guys in next classes. Bye. Take care. See you.